chapter 11. Of course, we finished chapter 9 last lecture, and we already finished chapter 10 after 4, you remember? So now we are in chapter 11. Okay, and am I recording, by the way?
Yeah.
Yes.
Yes, good. Good enough. Good. Next, what's the title of chapter 11?
Intermolecular force and the physical properties of liquid and solid.
Yes, liquids and solid. In chapter 10, what did we study?
Gas.
The gas.
So this is gas. Now we're going to talk about liquids and solids. Liquid and solid. Good. Next. Difference between the gas, the liquid, and the solid. The gas, the forces between the molecules is not there, and that's why each molecule is by itself. Can you see it? So
Yes.
the forces is for gas, the intermolecular forces is very weak. All right, and that's why each molecule it's by itself. How about for liquid?
Strong.
It's not strong, very strong. It's strong, maybe I will use strong, but not very strong. Why? That's why liquid, each molecule, they're moving, they can move. But how about solid?
Very strong.
Very strong.
The strongest.
Of course, very strong. Look, when you have solid, each molecule is staying in its place. It cannot move. See, each molecule is staying in its place. This molecule is there. You cannot move it. You cannot move it anywhere else. But for the liquid, if the molecule is here, you can move it and bring it here, or this molecule can move here. But in solid, each atom is, or each molecule is exactly in its place. Why is that? What's the difference between them? The intermolecular forces.
Doctor.
Yes.
Is the intermolecular forces is the same element or it is different?
It's different from one element to the other, of course. But we're talking about what type of forces. We're going to talk about what are these forces. Now we're going to talk about what are these forces. All right. For solid, let me start with the solid first. Give me example of compounds or molecules that are solid.
Iron.
Iron. Iron is element and it is solid. Iron is solid. Give me another example.
Platinum.
Aluminium.
Another compound. NaCl is solid. First, let me tell you this. All ionic compound are what?
Solid.
Solid. Why? Because the intermolecular force between them is very strong, which is what?
Ionic.
Ionic bond.
Bonds.
Very good. So all ionic compounds, what type of force is between them? Ionic bond. And the ionic bond makes
Very
them
strong.
all, they become what? All
Solid.
solids. So whenever you see ionic compound, you don't have to think Is it solid or liquid? It is solid. Clear? So if I tell you we have calcium carbonate, is this solid or liquid?
Solid.
Solid, solid. All right. I'll give you another, for example, sodium bicarbonate. You know what's this sodium bicarbonate?
Yes.
هذه الخميرة من الأكل. Is it solid?
Yes.
Yes.
Why?
Ionic.
Ionic.
Another example. All metals are solid except Hg. Okay. Why? Because the forces between the solid, the element is called metallic bond. Metallic bond. And it's also strong and it becomes solid. And that's why Fe, iron is solid. How about aluminum?
Solid.
How about sodium by itself? Solid. Potassium.
Solid.
Solid. Most of the liquid, most of the elements are solid. There are exceptions like Hg. Do you know another example? CS is
Cesium.
CS, which is cesium. Look at, go and see your CS in your periodic table. Okay, where is cesium?
Liquid.
It is liquid, yes. Cesium is liquid.
Doctor,
Yes,
what about helium? Isn't it a gas?
it is gas. Is it metal?
No.
Okay. I'm talking about metals,
Okay.
not any element. Helium, hydrogen, oxygen, nitrogen, these are non-metals. So we know that there are two strong forces already. What are these two strong forces that you know now?
Ionic bond.
Ionic
And
bond.
metallic bond.
Metallic bond between what? Metals. And the metal itself.
Metals.
Not non-metal. Be careful. Good. Very good. How about the others? Like, for example, non-metal with non-metal. These are becoming what's called molecular compounds. Molecular compounds have three forces. The forces between them, these are generally called van der Waals forces. Van der Waals forces. You have to memorize the name very well. Van der Waals forces. Okay. These take place between what? Molecular compounds. What do you mean by molecular compounds?
Between molecular and another.
Yeah,
Non-metals.
by molecular compound. Non-metal
With non-metals.
Non-metal.
with non
Or metalloid.
or metalloid with non-metal or whatever. Yes. Okay. What are these forces? There are three forces. There are what's called Dibull Force. These are very weak forces. Okay. And these are, we can see things like HCl is gas. Water is also molecular compound, and we see what type of forces, what type of, what's the physical property of water? It is liquid. All right. And we can see molecular compounds like, for example, sugar. What's sugar?
molecular.
C6, H12,
H12
O6.
O6.
6.
O6.
It's molecular compound, but it is solid. So we can have liquid, we can have solid, we can have gas. Why is that? Because of the intermolecular forces. Intermolecular forces. Clear?
Yes.
Okay, good. What type of forces we have? We have the first one is called dipole-dipole interaction. Dipole-dipole interaction. If you have HF molecule, which is more polar, F or H, more electronegative.
Fluorine.
Fluorine. I wanted you to memorize the electronegativity of fluorine only. What was it for fluorine? 4. Don't forget this. While for hydrogen it was what?
2.1.
2.1. So if these become together, what will happen? You will have a force like this. Right? And now, if you have HF molecule like this, this is H, this is F. What type of force is going to be here? Partial what?
Partial negative.
And here,
Partial
Positive.
positive.
if you have another molecule, and you have H here and F here, you have also partial negative, partial positive. What will happen between these two molecules?
Make a compound.
What?
Attraction forces between them.
Attraction. What? Why is that attraction?
Other.
Partial positive with partial negative
Partial negative
from
and
each molecule.
positive attract each other. And that's why this is called dipole-dipole interaction. Okay, memorize the name. What's the name?
Dipole interaction.
Dipole interaction. It takes between what and what?
Between two molecules.
Polar.
What?
Polar.
Yes, that's the most important one. Between what? Polar molecules. It takes place between polar molecules. Is this clear? Any questions?
Yes.
Very good. Next. These are all, the force between them is polar. And look here, there is, what's the electronegativity of carbon? Do you remember it?
2.1.
And hydrogen. I want you to memorize fluorine is what? And then oxygen after it.
3.5.
Good. And then nitrogen.
3.
Yes. And then carbon.
2.5.
And then boron.
2.
Yes. And then I ask you to memorize also hydrogen, which is 2.1. The difference between carbon and hydrogen is considered to be what? Almost.
2.4.
Why?
It's less than
0.5.
0.5.
Look at the boiling point of propane, minus 42. Very low, because there is no polarity. Okay? Look at this compound. Is there polarity? Is there polarity?
Yes.
Yes, of course.
Yes.
That's why, look at the boiling point increased. Look at CH3Cl. CCl. Is there polarity here?
Yes, also.
Temperature is there.
Yes.
Okay. Look at CH3, CO, CH. 3, C double bond O. There is polarity, and look at the boiling point.
Yes.
The last one is CN, CH3, also this one. So as the polarity increase, what happened to the boiling point?
Increase.
Increase. Very good. Then what's the name? What's the name of this force?
Dipole interaction.
Dipole interaction. Don't forget it. Okay? And what's the condition? It takes place between what?
Polar covalent molecules.
Polar compounds. Polar compounds, exactly.
So propan polar doctor, right?
Polar compounds, yes. Next, the second force that we should know is called hydrogen bonding. Hydrogen bonding. This bond is also dipole, but it's very special force. Very special. It's type of dipole, but very special dipole, and much stronger. Hydrogen bond is H bond is much stronger than dipole, simple dipole. Even though it is dipole, but it is special dipole. This hydrogen bond takes place when you have hydrogen directly bonded to three elements only, which is oxygen or nitrogen or fluorine. If the hydrogen is bonded to fluorine or to oxygen or to nitrogen, then the force becomes very strong, and it's called hydrogen bond. Hydrogen bond. All right? And we can see this hydrogen bond in this table. Look at the boiling point. This is the boiling point of the elements which are similar, which is H2O, H2. Look at the periodic table. What's under H2O? H2S. And what's under H2S? H2SE. What's under H2SE? H2TE. These are under each other from your periodic table. All right? Look at the boiling point. The boiling point of H2TE is more than HTSE, and then more than H2S. But look what H2O, it should come, if it's normal, it should come here, H2O. Clear? But we find that H2O become here. Why is that? Because of hydrogen bond. Is this clear? Very good. Look at the elements under nitrogen. What do you have under nitrogen? We have NH3. What's under NH3?
PH3.
What's under P3?
ASH3.
And then what's under it?
SP.
SP.
SBH3.
H3. Exactly. Again, look at the boiling point of the green line. This one become lower for ASH3, become lower for PH3, but when it comes to H3, it becomes like this. It goes up, not down. Why is that?
Because the
Hydrogen
hydrogen bond.
bond.
Exactly. And the same for the rest of the elements. Look at the one under carbon. CH4, what's under CH4?
SiH4.
SiH4, what's under SiH4?
GH4.
GeS4.
And what's under GeS4?
SNH4.
Okay, look at their boiling point. Like this, like this, like this, and like this. Why
The
is that?
same trend.
Why?
No O or F or N.
Yes, no H bond. What's the condition for hydrogen bond? It has to
Polar,
be
between polar.
no hydrogen and what?
N and O and F.
N or
Oxygen.
O.
Or
Hydrogen.
O
Right.
or F only. It must be directly bonded to them. Okay.
Why doctor, is that?
Can we have hydrogen bond between O2 and HCl? H3, I mean H3C, C3. Can we have hydrogen bond between hydrogen and oxygen?
Yes.
No. Why not?
It is on the carbon.
The hydrogen must be what?
Alone.
Directly connected to the O.
Be connected to the one of these three elements. What are the three elements?
Nitrogen, oxygen, and fluorine.
Yes. If we have H with F and we have water, can we have hydrogen bond between this H and this O? The answer is yes. Why?
Why not?
What?
H could be HF, HO, HN.
Because hydrogen is directly bonded to fluorine. Can we have a hydrogen bond between this one and this one?
Yes.
Why?
Directly bond to oxygen.
Directly bond.
Excellent. And the hydrogen bond is much stronger than the dipole forces. Then there are third forces, which is called London forces or London dispersion forces or dispersion forces. I want you to memorize London. This is called London, you know, the city of London. London dispersion forces. This is London dispersion forces. It's known usually as dispersion forces. Rarely we say London. We say dispersion forces, but sometimes we say London dispersion forces. Clear? Okay. These dispersion forces take place between all molecules. So all the molecular compounds can have dispersion forces. But the bigger the molecule, the stronger the force. Okay, so we talked about three forces, which is dispersion forces, dipole, and hydrogen bond. Let me ask you now, dipole forces take place between what and what? Dipole forces.
Polar compounds.
Polar.
Very good. That's it. Okay, hydrogen bond take place between what and what?
H and O, F or N.
Oh,
What's the condition?
Must be directly to one.
What's the condition?
must be
Directly.
direct.
Exactly. Dispersion forces take place between what and what?
All molecules.
All molecules.
All molecules. When it becomes important,
With bigger molecules.
the bigger the molecule, it's more important. Good. Let's solve this problem. CCl4, what type of forces we have between them?
Dipole.
Wrong. You remember CCl4 is, this is CCl, Cl, Cl, Cl. This is AB4, E0 from chapter 9. Is this polar or non-polar?
Non-polar.
Non-polar.
They cancel each other.
Non-polar, they cancel each other. Then what type of forces we have here?
London.
Dispersion.
London only.
Only dispersion. Only dispersion. Very good. All right. Let's look at this one. CH3COOH. CH3COOH. What type of forces we have?
Hydrogen bonding.
Dipole and diversion.
First, dispersion. Is it available?
Yes.
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 Yes,
Why?
between C and H.
No. Why dispersion is available?
Because it's
It's
in all
molecular.
molecules.
In all molecules. Very good. Okay. What type of other forces we have in this compound?
Dipole.
Where is the dipole?
Between H and O.
Between H and O. This H and O. This is dipole. Exactly. So we have also dipole. Yes. Okay. What type of other forces we have?
Hydrogen bond.
Yes. We also have H bond. Why?
Between O and H.
And it's directly bonded to O. What's this compound? CH3COOH.
Ethanol.
No.
Citric acid.
Carboxylic.
Acetic acid. ايش هو الاسيتيك اسيد؟
خل.
خل.
تعرفون الخل ليكويد ولا غاز؟
Liquid.
Liquid. Very good. All right.
Sure.
Good. This compound CH3 C double bond O CH3. What type of forces we have in this compound?
Dispersion force.
And dipole.
Dispersion. Somebody said dispersion. Is he correct?
Yeah.
Yes, between all molecules.
He will be always correct. Okay. Why?
Because
It's
it's
molecular.
molecule.
Any molecule. Exactly. Okay. What type of other forces we have?
Dipole.
Dipole between this one and this one. What else? Do you have
No
hydrogen?
hydrogen.
Hydrogen between this oxygen and this hydrogen?
No, it has to be
No.
directly bonded.
Exactly. No hydrogen bond. So we have only two forces: dispersion and dipole.
Dipole between C and O, right, doctor?
Exactly. That's why I draw this arrow. Good.
Excuse me, Victor. How do we have dipole when it's the domain is AB3?
Yeah, because there are different terminal elements.
Okay, yes.
Yeah, when you change the terminal elements, then everything changes. Last question. What type of force is between H2S?
And dipole.
Dipole. Why? Because they don't cancel each other.
Yes, polar.
It's polar, and that's why there is dipole. And then
Dispersion.
what's the other force?
Dispersion.
Dispersion. Exactly. Dispersion. Let me ask you a very quick question also. CH3, CH4, and C2H6. What type of forces between these two compounds? I mean, then each one by itself. What type of forces for this compound? Only dispersion. There's no dipole, no hydrogen bond. How about the other one? Also dispersion. Which one will have stronger dispersion? First one or second one?
Second.
Why?
That's
It's
bigger.
bigger.
Exactly. That's it. Good. Okay, next. Yes, just a second. What type of other forces we have? We can have also between ion and dipole. Why is that? Why this force take place?
Charges, because of the charges.
What is the charges?
Na is positive, and then the dipole has partial charges.
Let's assume that this is water. This is oxygen and hydrogen and hydrogen. What will happen? If we have water,
always
attract to O.
partially what?
Negative.
Negative.
Negative. And hydrogen partially
Partially positive.
positive. So what will happen between Na plus and the water?
Attract.
Attraction.
What type of interaction is this called?
Ion dipole.
Ion dipole. Ion dipole interaction. Let me ask you a very simple question. This is water and this is water. Okay, this is water and this is water. Why number 2 is stronger interaction than number 1? This is 1 and this is 2. Why 2 is
Smaller.
stronger than
Because the
1?
charge is bigger.
The charge.
The charge is bigger.
And
What
it's smaller.
The size is smaller.
The size. So the area, this 2 plus is in smaller area than the 1 plus in this bigger area. Charge and size. And that's why this force is much stronger than this force. Okay? If I put a third one like aluminum, which is Al3 plus, which is extremely small with water, what type of force we're going to have? Ion dipole, and it will be very strong. Clear? Good. All right. Next, we're going to talk about, we talked about solid, interaction. We're going now to talk about liquids. Liquids. Now, when you put water in a cup like this, then there will be forces between the molecules in the, like these are the water molecule, there are forces between the molecules. Look here, look at this molecule here. And then let's take this molecule. What type of forces does it have? There will be forces between here and here and here and here and here. And so it is, there is forces from everywhere holding it together. But what will be the net force for this element, for this compound, or for this molecule?
Zero.
Zero. Exactly. How about this one? What will be the net force between all the forces? It's also zero. But look at
Zero.
what is the net force?
To the down.
Not zero.
To down.
This is called surface tension. Surface tension. And that's why when you put water in a very small tube like this, you will find that the water is coming down like this. Tell me why.
Why?
doesn't equal to 0.
Why? What's the reason? Why the liquid? If you look at a very small tube, very, very small tube, like this, you will find that if you put water in it, you will find the water is surface is like this. This is called, because of surface tension. Why is that? Because the molecules are trying to hold the atoms down like this and bring the liquid from the surface become like this because of the force going down. This is called surface tension. Surface tension, very important word. All right. Also, there will be attraction between the molecule of the tube and the liquid. So if you have liquid here and you have the tube, you will find the liquid is coming to the tube like this. I'll give you example. When you go to the doctor, look at this. when you go to the doctor and they punch your finger and they put the tube like this, what will happen to the blood?
Become like a ball.
Will go to the tube.
Well, why the blood goes to the tube?
Traction
Because of
between the
tension
tube
force.
and
Between what and what?
the
Between
blood and
the-
the tube.
Tube
And-
in the blood.
And the wall of the tube. The blood will be attracted to the wall of the tube, and that's why the blood starts to go up like this. This is called capillary action. Capillary action. So I wanted to memorize two words. What's the meaning of surface tension?
The force to attract the molecule to down.
Yes, the force try to make the molecule goes down like this. As I said, if you have a small tube, I'll make the tube wide, but it's actually, it must be very small to see it. And what will happen to the liquid? You will find that the liquid is coming down like this. Why is that? Because of what?
Surface tension.
And why the tube goes, why the blood goes in the tube like this?
Capillary action.
Capillary action. And what's the reason for capillary action? There is attraction between the liquid
And the
The
tube.
wall.
and the
Wall
tube.
of
And the tube. Okay? All right. These are the attraction between the water molecule is called cohesion. Cohesion, it's between, like this one in the surface tension, the force is between what and what?
water molecule.
Water with water. Okay? But in the case of blood, it's the forces between what and what? Between the blood and
Blood in the tube.
the tube. If it's between the same molecule, it's called cohesion. So surface tension is what?
Cohesion.
Surface tension is cohesion. What's adhesion?
Capillary action.
Like example is the capillary action.
Doctor,
Yes.
do we call cohesion concave?
Yes, just a second. We'll talk about this one. Okay. When you go to liquid now, no, sorry. When you go to liquid now, you will find in certain tubes, the shape is like this. In certain tubes also, you will find the surface is like this. Oh, what's happening? This one is because cohesion is stronger than adhesion. And in this one, where the tube, the liquid comes up like this, what's the reason? Because adhesion
Stronger than cohesion.
is stronger than what?
Cohesion.
Is this clear now? I want to memorize this. Clear? Very
Yes.
good. Next, viscosity. Very important word. What's viscosity? What's viscosity?
Resisting of movement. For liquid.
Resistant to flow, or yes, actually, I like this one also. Resistant to move. Resistant to move. What's viscosity? Look, let me tell you example. If we have water and honey, which is more viscous?
Honey
Honey.
Why?
has high resistance to movement.
Has a bigger
Has
viscosity.
resistance to flow.
To flow. It does not like to flow or does not like to move. It's very, this become, which is more, if you have liquid, both of them, of course, solid. I mean liquid. This is liquid and this is liquid. But which one is closer to solid?
Honey.
Honey.
It's closer to solid. This means which one is having more intermolecular forces?
Honey.
Which one is stronger? Intermolecular
Honey.
forces. Honey or liquid or water?
Honey.
Honey. Very good. Is this clear? Okay. Now, also I want you to memorize another word, vapor pressure. What's the meaning of volatile?
Able to being a vapor.
Liquid.
Readily vaporizable.
Liquid goes to what?
Gas.
To
Vapor.
gas. Liquid goes to gas. That's the meaning of volatile. Liquid goes to gas. Is this clear? That's the meaning of volatile. Okay, which is more volatile? Perfume or something like actually
Water.
water has no smell. That's why, of course, water is volatile. But which one is more volatile? Perfumes or water? Which one?
Perfume.
Perfume.
Why is it? How can you tell it's more volatile?
It can be smelled.
It will become gas and you can smell it, and that's why it is volatile. Volatile. Is this clear? Okay. So I want you just to know what's the meaning of volatile. What's the meaning of volatile?
Vaporizable.
Liquid goes to what?
Yes.
Liquid goes to gas. Good? Okay. Now, when liquid goes to gas, what will happen if this is liquid and we have it in a closed container like this? If this is liquid and this is liquid, liquid A and liquid B, they are both in this same container, same size container, liquid B. And let's say that B is more volatile. Now, what does that mean? A will make pressure. Some of the molecules of A will come out to become like this. And B will also come out like this. Which one will have
pressure.
more vapor pressure?
B.
The pressure in B is bigger
Why?
because it is more volatile.
And if it's more volatile, what does that mean? Look at my drawing.
Has a high vapor pressure.
Yes, a lot of it will become more vapor than A. Look, I made very many circles for B, but little for A. Why? Because this one is more volatile. There will be more molecules out and more vapor pressure. Clear? What will happen to the vapor pressure if I put more of an increased temperature?
It should
Will
increase.
increase.
What?
The vapor pressure will increase.
Okay, give me proof of this. About water.
When you boil water,
when you start heating water, when it's at 25, you can see no vapor at all. 25 degree, no
Of
wave.
the balloon. You
Huh?
heat
But
the
how about
balloon, it will
75? At 75, what will happen? You will see some vapor coming when you boil water, right?
Yes.
How about at 100?
It's all vapor.
A lot of vapor, a lot of vapor, right? So generally, when you increase temperature, what will happen to the vapor pressure?
Increase.
Increase. And we're going to call the vapor pressure as P pressure, right? So I'll call this one P1 at 25, P2 and P3. Which one is higher, P1 or P2 or P3?
3 and 4.
P3 is higher. So this is the relation between the drawing here between the temperature and the vapor pressure. As you increase the temperature, the vapor pressure increase. Now, I want you to memorize very important relation. Memorize the relation. What's the name of this relation? Calcius-Calibran equation. I want you to memorize the name. Calcius-Calibran equation. And this is the equation. This is one form of the equation, but not important. The one which is more important is this one. This is Calcius-Calibran equation. I want you to memorize this equation extremely well. Write it from now, and we will solve a problem right now about it. Memorize it and write it. Now I want you to tell me what's the meaning of ln.
Logarithm to base E.
Logarithm of E.
Natural logarithm, yes, natural logarithm. Okay, and it's available in your calculator. Look at your calculator. You have the word ln, HN, which is logarithm. Okay, what's P1?
First pressure.
Pressure 1.
Vapor pressure at what temperature?
First temperature.
Temperature 1.
And what's P2?
Second pressure.
Pressure in T2.
Pressure at T2. Okay, what's R?
Constant.
Which constant? Which constant?
0.080.
Table, tell me what's this gas constant? Which one?
0.08.
0.0806.
Wrong. We should use which one?
8.314.
Why is 8.31? Because I want the unit what?
Joule.
Joule. Why I want the unit joule? What's delta H?
Kilojoule per mole.
It's what's delta H VAB? What's the meaning of delta H VAB?
Heat.
It's the heat for
Heat
what?
of evaporation.
Heat of
Vaporization.
Can you write a reaction for water to represent the heat of evaporation?
H2O.
Liquid. H2O gas.
Exactly, that's the equation that represented, and delta H for this reaction is called delta H vaporization. Did you memorize this equation?
Yes.
Okay, write it in your notes. We will solve this problem right away. I want you to solve this problem. Okay, the vapor pressure of diethyl ether is 401. So what's 401 in this case?
P1.
P1.
Exactly. At 18 degrees C. What's the 18 degrees C?
T1.
T1. Don't forget to change it to what?
Kelvin.
Kelvin.
And its molar heat of vaporization is 26 kilojoule per mole. Calculate the vapor pressure at 32 degrees centigrade. What's the equation that I have to write? Len, what?
P1 over P2.
What's P1? I want to write numbers right away.
401.
Okay. Divide by
76.
By X. B2.
P2. Should I change the to make it atmosphere or keep it as it is?
You can
Keep it as it is.
Why?
It cancel each other.
Exactly.
Nothing will change.
Both of them is millimeter Hg, so they will cancel each other with no problem at all. Okay, very good. This is equal to what now?
H vaporization.
What should I write?
26 over
26,000.
Yes, I have to multiply by 1,000. Why? Because I want the unit as what?
Joule.
Joule.
Because R is in Joule.
And also R is, what's R?
Over 8.314.
And this is per mole. And this is per mole degree. I mean, not degree, but Kelvin. And the mole will go with mole. What's left? Only K. Very good. Multiply by what now? 1 over?
1 over 32 plus 273 minus 1 over 18 plus.
The first one is T1.
No, it should be.
No, it's T2.
T2, sorry.
T2.
Yeah, I made a mistake. Sorry. T2. So it should be what? 3. Add them together.
305.50.
3 what?
305.50.
Very good. And what's T2?
291.50.
Very good. So calculate P2 quickly. Give me an answer. I need an answer. Go ahead. Use your calculator and give me the answer.
656.5.
Fantastic. Anybody else?
Yeah, same, doctor.
Are you sure? So the answer is what? 600?
656.5.
656.5. Okay, fantastic. Yes, maybe. I don't know what's the answer, by the way. I'm depending on you. I can assure you that there will be one question in the final similar to this question. I don't know which one he will give you. Maybe he'll give you the temperature or give you the pressure or give you anything, but there will be a question like this one and you have to solve it. You now solved it. In the final, solve this question. Is this clear?
Yes, doctor, why do we have to change to joules?
Because the unit of R, what's the unit of R?
8.
Look at your periodic table. Right?
Oh, it's joules, okay.
Okay. Or if you want, you can change the R. You can make the R as 8.31 times 10 to the power minus 3 kilojoule per mole. And then keep this one as 26. Can we do that?
Yes.
Right? And then we keep the heat as 26 kilojoule. No problem. Which is the same, by the way. There is no difference. Is this clear? Very good. So we're doing fine. Next. Now we're going to talk about solid. Now we finish with the liquid. We're going to go solids. Now we're going to talk about solid. In the solid, we have what's called crystalline compound. What's the crystalline solid? Crystalline mean is very ordered. Crystalline, I want you to memorize the word crystal or crystalline. What's the meaning of crystal or crystalline?
Special geometry.
Order.
Very old.
Order. What's the meaning of order?
arrangement for the atoms.
Arrange, منظم. All right. Is this crystalline compound? B. Is it crystalline compound?
Yes.
Why?
Same order, same trend.
Same trend. Okay, very good. Can you see the elements are very, very well ordered? What do you call this compound? What's the word?
solid.
Crystalline solid. Crystalline solid means very ordered. Good? Okay. Now, if we have crystalline solid, each point is called, there is a lattice. Lattice. Lattice means, what's the meaning of lattice in Arabic?
Ballora.
Ballura or khaliya? I don't know. I think khaliya maybe. Or ballura, I don't know. No, crystalline is ballura. Crystal is ballura. I think crystalline is ballura. And
Bunya.
or bunya, I don't know. And lattice means khaliya or bunya. Bunya, maybe. I like this word, bunya. Because
Shabaka.
Shabaka, oh, yes, Shabaka. Lattice means Shabaka, yes. Yes. Now, look at this Shabaka here. It is clearly, there is lattice points. Lattice point. Okay, each point, first, if you take this one, if we take a very small part of the lattice, this is the crystalline compound. And if you take 1 unit, we call this one crystal unit cell. Unit cell. خلية بس أحادية. يعني A, if you make A become with A, another A, put another A beside it, you'll get B. A plus A plus A plus A plus A, many A's, it will become B. Clear? So this is called, I want to memorize the word unit cell. What's the meaning of unit cell? Smallest
Structure.
smallest part of what?
Crystalline solid.
The crystal. Smallest part of the crystal. Very small part. All right. What do you call these points? We call them lattice point. Lattice point. Is this clear? So I want you to memorize 4 words so far. What's the meaning of crystalline solid?
Very ordered.
Very ordered. What's the meaning of lattice structure? Is how it is built. The shape or structure. All right? Very good. What's the meaning of unit cell?
The smallest part
of a crystal.
Very good. And what's the meaning of lattice point?
Ions, molecules.
The part, the edges of the unit cell. The edges of unit cell. Or of the crystal or crystalline compound. What do we call these points? The blue points here. Lattice points. Clear? All these blue things are called lattice points. The type of structure of the crystalline, we can have many structures like this one, this one, this one. We don't care about all of them except this one. I want you to know this one only. So forget about this one. Don't even look at them. What's the name of this one? All these are unit cells, but these are too advanced for you. We want only one unit cell, which is important. What's the name of this unit cell?
Simple cubic.
Simple cubic. Memorize it. Simple cubic. What's the sides of the cube? A, B, C, they are what? Equal. And what's the angle? Beta gamma. Gamma.
90 degrees.
Beta gamma. What's alpha beta gamma?
90 degrees.
All of them 90 degrees between the faces of the lattice. I want you to memorize only this one. Memorize this unit symbol. What's the name of it? Again.
Simple cubic.
And
Simple
what,
cubic.
and what's A, B, and C? What's the property of A, B, and C?
Sides are equal.
They are equal. This is the side. And what's alpha, beta, gamma for all of them?
90.
90 degrees. Don't forget this. The rest, don't worry about it. Don't even look at it. Okay? Good. Now, I want you also to know the meaning of coordination number. Coordination number is the number of elements around X. For this structure that you're looking at, how many around X now?
8.
8. Exactly. 8. All right. But I'm cheating you now. Why? Because these are 8, but I'm showing you only one face. How about if I put a face from the front and the back? What will happen? How many will be around the X?
16.
No.
10.
10. Right?
Yes.
One in front and one in the back. Okay? Okay. This is called coordination number. Coordination number. So what's the meaning of coordination number?
Number of elements surrounding.
Surrounding a certain compound or element. This could be X could be element or compound. It depends. And are these involved in the coordination? Because we have elements here. Can we count these now?
No, just the touching elements.
Yes, the closest. This one, this one, this one, this one, one in front, one in the back, and then at the same time, the second closest, which is this one, then the one which is touching it, and the one which is actually, because these are actually touching each other like this, but we cannot see them very well. Okay, but we cannot see them in the drawing here. These are closest, yes, but these are also very close and they are touching each other, and that's why there's a part of the coordination. Actually, the coordination number usually is about 12 elements, or usually the coordination number is 12. So memorize this number. What's the coordination number? Is about 12. Clear? Very good. Next, we have 3 types. I told you that we have, I told you to memorize cubic structure. Cubic structure. We have 3 types of cubic structure. We have what's called primitive cubic, body-centered cubic, and face-centered cubic. I want you to memorize these names. Primitive cubic, body-centered cubic, and face-centered cubic. Memorize them. What's the difference between these? They are all, but what's the difference between them? In the simple cubic or primitive, ايش معنى primitive?
بدائي.
Very simple. Very simple. You'll find that the one we saw just a while ago. Where are the lattice points?
On the edge.
On the edges, exactly. How about the body-centered cubic? Where are the lattice points?
On center.
On the
edges.
Edges and center.
And one in the center, inside the cube. All right. Okay. How about face-centered cubic?
Edge and
the edge, like the primitive, but there is one on the face of the cube, not inside. This one is inside the cube. This one is in the face of the cube. So if I draw the face here, you will find that there is one here, one here, one here, one here, and one in the center of the face. Clear? This is called face-centered cubic. Okay, now I want you to go, I will stop here with this chapter, and again I want you to go to extra. Let me close this completely. You remember I told you to go to okay, in your Blackboard, you will find, I told you from last time, there is a file called extra. Chapter what? 19 and to 13.
9 and 13.
I hope you go to that one, because I want you to memorize one thing in this table, which is extremely important. Okay, this chapter, you remember this is the extra. You have to go to the extra. And in chapter, this is what I gave you, this table about chapter 9. And then I gave you, now we are in chapter 11. This is from me. I want you to look at one. Okay. We will go back to the rest. But I want you today to memorize this cubic structure. Okay. If you have this cubic structure, we said that we have 3 important cubes. What are these 3 cubes?
Primitive,
Symbol,
primitive, or what is the name of the other one?
Symbol,
center cubic. What's the name of the third one?
Body center.
Body center cubic. I want you to memorize 2 things also in it. This is the number of atoms or molecules molecules. But let's talk about mostly atoms. How many atoms in the cube, in the symbol cubic? How many?
4.
No, symbol cube.
1.
And memorize, just memorize it. 1. How about in face-centered cubic?
4.
How about in body-centered cubic?
2.
2. Write this in your note. It's available for you. This table is available for you. In extra, you have to memorize it. I want you also to know 2 things. Another thing. What's the meaning of R? What's R?
radius
Radius of what?
Radius.
of the atom.
Of the element. Of the atom. Okay. What's R? What's A? Sorry. What's A?
Number of atoms?
No. H of
Lattice points.
what?
Lattice points.
Edge of the cube. Edge of the cube. What do I mean by the edge of the cube?
رؤوس.
What do you mean by edge of the cube? Let's think. Right? Let me repeat one more time. We have 3 types of solids. What are these solids? What are the cubes? How many cubes you have?
3.
What's the name of the first one?
Simple.
Primitive or simple cubic. What's the other? The second one?
Face-centered cubic.
Fantastic. What's the name of the third one?
Body-centered cubic.
Okay. The second question. How many atoms are there in simple cubic?
1.
2. 1.
Memorize this. Memorize it and write it because we will solve a problem right now. Okay. How about face-centered cubic? How many atoms are there in the cube?
4.
4. Memorize it. If we have body-centered cubic, how many atoms are there in the cube?
2.
Memorize it and write it in your notes.
How is it 2 exactly and 4? I don't
Huh?
understand. You mean the structure has 4 atoms or how exactly?
The cube has 4 atoms in the cube.
Center got 5. The 1 in the middle and the 4 in the corner.
La. We are saying, that's why I say this is the coordination number. But I'm saying that in the cube there is actually in the simple cubic there is only 1 because the compound is sharing. And I'll explain this to you. But I want you just to memorize this very well.
Okay.
Also, what's the R?
Radius.
Radius of the element. Okay, this is R. Radius. What's A?
The length of the side.
Edge of the element. What will be the volume of the cube?
A cubed.
A cube. Don't forget this. A cube. Is this clear? I want you to write these things and we will solve a problem right away about this table. I want you to memorize this table, and I can assure you also there will be one question in the final about this table. Memorize it and memorize it very well, and I will give you the question right now, and I'll go back and explain things to you later on, but I want to solve this problem. Okay, but did you write the information here? It's available for you in the extra, but I want you to write it to solve the question that we're going to do right now. Okay. Done. Good. Discard. And then let's go back to chapter 9. Chapter 11, not 9. Oh, sorry. Old crystalline cubic close back. Cubic close back. And it is, what is it now? Read this.
Face center.
Cubic. So how many atoms are there in the cube?
4.
4. 4. Okay. The density is 19.3 gram per centimeter cube. Calculate R. Okay. If there is 4 atoms in the gold, 4 atoms. Gold, this is AU. There are 4 atoms per cube. What's the mass of this? What's the mass of each atom?
6.022 multiplied by. Oh, I've got this number.
No. What's the mass of the atom AU? Look at the periodic table.
107.
107 point what?
196, though.
Okay, give me the number. I don't know. I'm depending on you.
196.97.
196 point
97.
97. What's the unit?
AMU.
AMU.
Now, very good. Now, if we have 4 atoms in the cube, because it is face center means 4 atoms per cube. What's the total mass? Give me a number quickly.
787.88.
787.88. AMU. Can you change AMU to gram?
Divide by Avogadro number.
1 divided by what?
Avogadro number.
Exactly. 6.022 times 10 to the power 23 AMU. AMU will go with AMU, and you have the answer is gram. So what's the mass in gram?
1.31 multiplied by 10 to the power minus 21.
21 what? Gram. Good? Gram AU, right? Very good. Now you have the density. Can you calculate the volume?
Yes, 4.
Go ahead, calculate the volume.
Attendance, teacher.
What's the volume?
6.79 multiplied by 10 to the power minus 20.
Okay. Before I finish, the attendance is open now. If anybody is in a hurry, he can leave. But let's go back to our discussion. Okay, what's the mass now? What's the volume?
6.79 multiplied by 10 to the power minus 10.
Minus 20?
23. Minus 23.
Are you sure?
Yes.
Centimeter cube, the unit, of course, because it's centimeter cube. All right, then can somebody calculate what's A?
It's a cube of this number.
Yes.
Cubic root.
Give me an answer.
Uh, 4.08 multiplied by 10 to the power of minus 8.
Okay,
Minus
what's
8.
the unit?
Centimeter.
Centimeter. Very good. Now, I hope you remember what's R, the radius, because that's what he's asking for, the radius. Can you calculate what's radius from the table? Did you write the radius in the table?
3 over 4.
What is it?
A root 3 over 4. Which is
I think it's root 2.
Yes, root 2.
Actually, the relation is A equal to what? R square root of 2. Is it? No, sorry. I see, I don't remember it myself. You have to memorize the relation.
It's R over root of 3.
Yes,
R
over.
is equal A root of 3 over 4.
Actually, yes. R is equal to A root of
Root
2
3 over
by 4. Exactly. You have
Isn't
to-
3, Doctor?
Huh?
Root 3. Isn't root 3?
No.
No, root 2.
No, in root 2.
Root 2, face center is root 2. In body center is root 3. Okay, then calculate what's R.
A is 4R over root 2.
Go ahead, calculate R. You have 8.
1.44 times 10 to the power minus 8.
1.44
Yes,
times 10
to the power minus 8.
To the power of minus 8.
minus 8. What's the unit? Centimeter.
Centimeter.
Can you make it in nanometer?
multiply by 10 to the power of 9.
It should be 14.4 nanometer. Right?
Yes.
And it's actually, yes. It is 1.44 angstrom. Okay, yes. This is the AR, yes, 1.44 times 10 to the power minus 8 centimeter. Okay, that's the answer. Do you know how to solve this problem?
Inshallah.
Actually, this is only. That's why I say you have to memorize. Is it 0.144 nanometer? Exactly. Okay, I want you to memorize how to solve a problem. I can assure you there will be a problem in the final exactly like this one. Not exactly like this one. Maybe he'll ask about the mass, or he'll ask you about things like that. But I mean, you should know how to find the problem from this question. Is this easy?
Yes.
Okay, we'll
Yes,
stop
sir.
here. Inshallah, see you Wednesday to continue the discussion. But today, please study what I gave you in chapter 11, and in the extra, go to the extra, memorize all the equations that I gave you, which are extremely important. Okay?
Oh.
Yalla, مع
Okay,
السلامة. See you Wednesday. There will be quiz in chapter 9 on Wednesday, inshallah.
Doctor, is the last quiz, right?
Doctor.
Maybe I'll see what I'm going to do about the. I don't know. Maybe I'll give you one extra quiz in chapter 11 because we have nice problems that we can solve also, and we can learn for final. I don't know. I'll tell you.
دكتور
نعم.
باقي اسبوعين تقريبا على الدوام صح؟
باقي بالضبط اسبوعين، وعندنا يعني باقي من اليوم، باقي اليوم محاضرة يوم الأربعاء وبعدين الخميس، بعدين الاثنين الأربعاء الخميس، بعدين الاثنين آخر يوم. آخر محاضرة حتكون يوم الاثنين، ويوم الثلاثاء عندكم الفاينل.
طيب الكويز شابتر 9 ما عندك تخليه الاثنين الجاي؟
لا. No way. I have to
لأن
do it.
في كويز بعده يعني؟
يوم الأربعاء اللي بعده بعطيكم، يمكن أعطيكم كويز في شابتر 11.
وبتحسب كيف طريقة الحسبة؟
As usual, the lowest quiz will be dropped.
اوكي طيب شكرا.
دكتور.
آخر كلاس يكون
نعم.
تاريخ كم؟ اليوم الاثنين تاريخ كم؟
اليوم اللي برمضان 14 رمضان يوم الاثنين آخر كلاس، و15 رمضان is your final.
اوكي.
دكتور.
نعم.
احنا توقفنا عند 9.6 9.7 مش معنى.
كيف again؟
أقول آخر محاضرة في chapter 9 وقفنا عند 9.6.
أيوة.
ف 9.7 مش معنى ولا كيف؟
مش مهمة. لا معنى بس مش مهمة، لأن الوقت ضايقنا، فمش مهمة، عشان كذا ما مريت عليها عمدا يعني. أوكي. Okay. يلا مع السلامة شباب. أنا I want to take a break and I'll come back. يا شباب على اساس تنزل المحاضره رجاء اطلعوا كلكم، وبعد 5 دقائق بفتح مره ثانيه وتقدرون تدخلون عشان تسالون. اعطوني بريك من 5 إلى 10 دقائق، بس رجاء اطلعوا كلكم وبرجعكم مره ثانيه بس عشان تنزل المحاضره.